For people that don't know me, I'm Ian Pilon, self-published author on this book called Cultivating Clarity. And that is about the contextual intelligence around product design. So I argue that context for your customer matters just as much, if not more, than the products and services that we're selling them. I'm also running a venture where I help small business, medium-sized business owners talk to their operational data just by voice. And I use AI in some of the workflows, and we'll talk more about AI into the show. But I also run a curiosity podcast where I talk to people way smarter than me. Today, I'm privileged to have William on the show to talk about and learn more about AI. My guest today is William M. Briggs, who argues that the phase of artificial intelligence is a category error that computers do not learn and that no machine will ever be sentient. He's a Cornell-trained statistician who wrote a book arguing that most of modern statistics rests on a philosophical mistake. So we'll cover introductions, why is AI poorly named, what is rational thought, what is reasoning, what is a large language model, how do they relate to probability? What are LLMs good at? Maybe what they're bad at? How is an AI agent different than a large language model? Is it even possible to build deterministic workflows in conjunction with LLMs? And why can AI not be considered sentient alive? I'll do a stop screen share here and just sort of like do this intro, and you can correct me if I'm wrong at any point here, William. But you publish under the tagline Statistician to the Stars. You have a PhD in statistics and a master's of science in atmospheric physics, both from Cornell. Started out as a cryptologist in the U.S. Air Force. Would love to hear more about that. Moved into weather and climate forecasting, then shifted towards philosophy of science, which is really cool. I follow a lot of your YouTube videos on this. William, welcome to the show. Thank you so much for joining me. Did I get that intro right? Would you correct it in any other way?
Makes me sound better than I am.
Okay. And one of the things about your book, Uncertainty, and then you have them in the background too, I don't know much about the one, Everything You Believe is Wrong, but they could be closely related. Maybe you want to help us understand your books and a little bit about who you are before we jump into it?
Sure. Uncertainty is not meant for the general public, although anybody could buy it. It's a book of the philosophy of probability and modeling in science in that order. There's some in-depth mathematical arguments in there and the like. And basically, it walks through the idea that probability is very simply stated, probability is in our minds. It's the extension and completion of logic. Logic is the measure of relationship between sets of propositions. And all that kind of reasoning, I guess we're going to talk about reasoning, that as logic. And probability is just the completion of that when we have less than certainty. Sometimes we don't have certainty. Either something is absolutely true or absolutely false. We have something in between, and that's what probability is. And that's what that book's about. The other book is undergoing a revision. The second edition will be out sometime this fall. So don't anybody buy this. Wait for the new one. I took the boring stuff out of the first edition and I put a bunch of new chapters in this one. It's the fallacies, the most common fallacies that we see around us every day. Like my favorite, of course, is everybody's heard of the appeal to authority fallacy. You do something because I said so and I'm the authority, which of course the person may be saying the true thing, but it's not because he is the authority that it is true. It's because the argument behind it that it's true. But our culture loves the appeal to non-authority fallacy. We believe when people are not authorities, when children, especially weepy-eyed children, try to sell us something, or when women are crying, keep us safe, or when celebrities try to do something as simple as selling you insurance or beer or whatever. Why should celebrities know anything about anything except where to stand, what to wear, what to say, what intonation to use, what face to make, all given to them by some director, and what, of course, words to use. But yet we take their authority to be supreme. So it's a whole bunch of arguments like that. I think it's a lot of fun.
All right. Very, very cool. And then I just have on a side note related to that, I use this sort of model, and I'll do a screen share here, where I try to find a way that I could use certainty and uncertainty to measure qualitative data, because in the work that I was doing, in tech. I've always been on the UX side, which just means user experience, or how people experience using tools, software or digital tools. And I've always had to argue against the data side of the data scientists who would argue using numbers. And I used to have to argue with just like, well, I've watched users, I've watched so many users do this thing, and then, this thing is either broken here or not. So I've ended up sort of following somewhat of trying to use a confidence scale to say, within some degree of confidence, I could say users are either achieving these goals or not achieving these goals. So have you seen anything like this before, like this type of epistemology map where you can at least try to say there's things that we believe versus there's things that are true? I was thinking that this was...
I think that's a pretty good picture.
Okay.
I've not seen your graph down below, but of course, that's what I say in this book here too. I mean, there's you could believe anything. You can believe absolutely anything. The stuff that you believe that happens to be true and can be proved as necessary truth, that's knowledge. You can only believe, knowledge is only truth, only true beliefs. By definition, it's a philosophical definition, but it's a good one because it helps separate out beliefs of things that are not fully certain. And it's not that the things you believe are always false. It could be because people don't understand belief is a decision, right? You have a degree of certainty about any particular statement or proposition, given whatever evidence that you're going to assume. And that will bring it to some probability like you have in your bottom line there. And then you might move to belief or unbelief. That's a decision on top of the probability. All right. It's a separate act of the mind. It's a entirely separate act of the mind. So anytime you come to a belief, it's one more thing that's above just looking at the evidence and what the evidence says about your proposition.
Yeah. Very, very cool. And then I found that, like, because I used to have to argue about the stuff that I was seeing from my qualitative research, and people wanted to know, well, how did you come up with that? And I'm like, well, here are 5 different interviews the way that people are talking about using this tool, so it still has subjective content in it, but it's better than just me saying it myself that I believe users are struggling here. Here's 5 users using the workflow and they are struggling or not hitting their goals. So okay, let's pivot to where I wanted to start this off, which was, why do you think artificial intelligence is poorly named? I know you have one of your blog posts that it's neither artificial nor intelligent. Maybe help us riff on this a little bit.
Sure. Well, it's neither it's neither artificial nor intelligent. I mean, it's obviously a computer running calculations, voltage levels, manipulating voltage levels, which we then interpret in certain ways. It's not intelligence of any kind. Anything could be a computer in a sense that we give meaning to the operations of the thing. So an abacus, a wooden abacus, the poles with the little beads on there you can flick up and down, that's just as much of a computer as the machines that we're all looking at this video on, right? So none of this is intelligent. Absolutely none of it has any kind of acts of intelligence. There's no intellection going on here. There's no intellection in the sense that there's no reasoning going on. There's no grasping of universals or truths or uncertainties or any of these things we just talked about. None of that stuff is happening inside a computer. It's not happening in an abacus. It's not happening anywhere but in our minds. And so the computer can model these things, and that's basically what we have. We have models of these things, which we could discuss what that means. But artificial intelligence itself, computer scientists, I say this all the time, they're absolutely brilliant marketers. I mean, they're absolutely, we've had neural nets, neural nets were these are neural nets. The real name of neural nets are, nonlinear regression. Now, nonlinear regression it sounds scientific and everything, and then, there's kind of meaty, but it doesn't have the same ring as neural nets. And then the computer guys came up with genetic algorithms. My God, these algorithms are evolving. That's wonderful. We could, they come up with these taglines which sell, and they're brilliant. They're brilliant taglines, but they're all just in the end models. They're nothing but models into which we define the language, the syntax of all of these models, and it's we who bring the semantics to the models, the understanding of these models. That's in us. It's not in the machines themselves. So artificial intelligence is bad. It's wonderfully named for for marketing purposes, but it's badly named to describe what is actually going on. If every time you see artificial intelligence or AI, substitute in your mind computer models, because that's what they are, you'll be less likely to run away and frighten yourself, or to overestimate or to underestimate what's going on, because models can be very useful, as we see. On the other hand, they have their strict limitations, as we also see.
Yeah, and I like the quote, all models are wrong, some are useful. I think that
That's attributed to George Box. I don't agree with it. I think
okay.
it's false. Many models are in fact true, and also useful. Bad models can be also absolutely useful too. Even absolutely rotten, terrible models that have no bearing on reality can be useful. And they're very useful in the sense I bring up the subject of Paul Ehrlich. I don't know if you remember, he died. Was it this year, last year? I think died last year. He was an environmentalist of the 60s. He projected there was going to be a population boom and millions, tens of millions, or was it a billion? I've forgotten the numbers now. We're going to die from this thing. He was wrong about every prediction he's ever made. Absolutely wrong. None of his models matched the world at all. But they were extraordinarily useful to him. He boasted that he had won every major award that science had going. He was promoted and feted and pampered and, given every possible deference to him. So the models were extremely useful to him, but absolutely useless to explain the world. So modeling, but you can have good models. You can have models that are true. Oh, I think I left them back there. You have a six-sided object, or an object that can take six states, and it's going to be in one of these states and none other. What's the probability this object is in state number one? Well, that could be a true model. There's nothing wrong with that model when you apply it to a die, for instance. It's a perfectly good model. It's not false. It's not wrong. It doesn't explain the full cause of what happens when you roll a die, for instance, or when you turn a machine on. So that's kind of what Box was, I think, aiming at, but without understanding that we're always after the cause behind things, and we don't always get it.
That's very helpful. That's already going to reshape my mental model. And one of the things that I love doing about calls with people like you, or
sorry, there's a plane going overhead.
Okay, yeah, is that I get to learn and change my mental model. So okay, so then if artificial intelligence is sort of like not the best name, and you call it computer modeling, what about large language models? Because would you say that is still a poor name for?
No, that's a good name.
Neural net. It is okay.
I like large language model. That's exactly what they are.
Okay, all right.
That's precisely what they are, and they, as long as people keep that in mind when they're using them, it's absolutely fine.
All right, so then let's go into what do you think they're good at or not good at?
All models are very good at finding the average behavior of whatever system they're modeling, whether that's a physical model or these computer models that they're training. So they're very good at identifying the tasks to which they're directed to do. And so, for instance, if you want to program a large language model, that's a very good search engine. You certainly can be able to do that. It requires looking at the queries that are brought in, manipulating those queries to make sense of them and matching the keywords, and then coming up with some algorithm that gives you high probability that the answers it's returning are what is wanted by the user. There's your user experience for you. And those absolutely can be fine. And they work very well. I mean, we've seen great improvements. I use Grok, for instance, Twitter's or X's AI model, their
Okay.
large language model for a search engine. But it has flaws too. For instance, I was thinking about one of these commenters out there, Rod Dreher, was making some comment the other day, and I was thinking, I remembered reading a book review of his by, I thought it was Florence King from back in the old days, where she basically excoriated a book of his about crunchy cons. I think that was the name of the book. And I couldn't remember exactly where, so I asked Grok to find it for me. And the model spit out an answer. And I've looked everywhere, I can't find it. But here's the book title, it told me. And the book, the review title of the Florence King thing. So I just put that into Google, and the very first link was right there online, everything. So they all have their strengths and weaknesses, and none of them are going to be good at one thing, wholly good, or unless it's absolutely designed to do that. With a lot of hard coding, what people don't understand, there's a lot of hard coding that goes into these models too. The routing of all these queries and how it spits out at you, all that kind of stuff is not a computer figuring it out for itself. That type of model is exactly like all models are fit. You give it data, you give it a function, and you fit that data to the function. That's all it is. And of course, the function in large language models is it's again like a nonlinear regression, exactly what it is, with lots and lots and lots, billions of weights attached to it. And that model will work in some instances, especially at the average behavior. But as you get out to the extremes, like all models, it will begin to fail.
Yeah. And what is your take on, I don't know, maybe if you've played with agents at all? So you're using Grok, which we know they're non-deterministic. So, but I was trying to get determinism out after I first discovered ChatGPT, and I realized, okay, this thing's never going to give me a straight answer, but that's the feature, not a bug. It could write me a great story. It can do really creative things, generate stuff, but it could never do the same thing twice. So I wanted to figure out how to get deterministic things while talking to it. I really like the value of talking to the machine. And then I got into agents, or figuring out how to get a tool call. Have you been playing around or heard anything about agents? Is it different?
Very little.
Okay.
But the determinism that you're seeking can only be there if it's put there by the coders, by the programmers. If everything is slightly I hate to use the word randomized, because people take that in a kind of a strange paranormal way, we should put it. But if everything is built like that, where they're using some sort of variable input, where the variable input is this randomization agent, then you're never going to be able to get it from these agents. And I've had, you could talk to Grok, you could talk to ChatGPT, and I gave it a task. I said, here, I want you to review this text for typos, because my enemies have a long history of inserting typos into my written work. So I wanted to just find the typos of this thing. And I said, here we go, find the typos. Don't change the text. Just show me the line number and repeat to me what the typo is. Oh, great, we're going to really do this. Here's the plan, ChatGPT. This is wonderful. Here's how we're going to go about it. We're going to do this, we're going to do this, we're going to do this. I said, great, let's do it. Okay, that's great. It kept promising we're going to do this. We're going to do this. Never got to the point. So you have to find a way to trigger the algorithm, because that's part of the input, the training input. You see, that the queries that it was used are all in the minds of the programmers. They thought this batch of queries provided by this source of data were the best way to put things. So you have to find a way to talk to the model in that data form that it was built by the coders. And even they might not understand exactly everything that has happened in these things, because, like I say, there's billions of these parameters that are being estimated. So
Yeah, and what I'm trying to do now is use deterministic traditional code and in the context where the customer needs specificity, but then I really like this idea where they can talk to the data. So that's where I'm trying to have the branching or splitting between, using some of the benefits of large language models with deterministic code to get real answers, not
Code is a good example. If are you trying to provide code to people? You're like,
no,
you're not.
No.
I see. Okay.
No. So what I'm doing is, if they owner or operator has different software systems or even pen and paper, I'm bridging them into, well, having a tool that they can get the data into.
Mm-hmm.
But then when he wants to talk to the data, for example, a customer who's leasing out trailers, the data's there, but it's in 5 different systems. Well, that's just a routing thing. So, but when he talks to the data, it can then get the gist of what he's looking for. Sometimes he's looking for data about the last time the safety was done on a trailer, and so I have the ability to converse or have a conversation with the system, but then it's very programmatic after that. It's like, okay, he's looking for data related to a safety, so then there's this way that it will then go into the system related to that, and the LLM is sort of out of the loop there, but brings it back. So an agent is kind of, at least what I've known from tinkering around with these things, is that it's then very restricted to how it does the tool call, and I limit it to its toolbox. It doesn't get to choose whatever tools it wants, but it's trying to just be helpful that it can pivot between toolboxes depending on what he says. So one instance, it might be I need a safety on when the last time the trailer was completed. They got to get, I think in Canada, we have to have a safety every year. And if he wants to lease a new one out, they want to know, like, okay, when was the last safety done before I lease it out? Or a different question might be, is it in the lot? Where is it right now? And it might be a different database that it goes and gets that through. So I'm literally still in the mix of building that out. But let's pivot over into, I think, a really hot topic where there's a bunch of people that are a little bit nervous about some of the headlines that come out of Anthropic and OpenAI, which are these ideas that agents are going rogue and sort of running off and doing their own things. And then it makes people nervous about, well, how are they doing that? Are they, so you talk about, that with this paper test show that you just did, AGI is not possible. Maybe we can go into a little bit around this and your thoughts on how AI cannot be considered sentient or alive, or how might you help us understand that a little bit more?
Well, there's several ways to attack the problem. The first is the abacus, as we've discussed. Is the abacus sentient? It has a state. It has the beads. You put the beads in a certain position, which we interpret to mean something. So hold that thought for a second. But in any case, the beads are moved by some human agency. But it doesn't have to be a human agency. You could have a series of mill runs, by water and everything that move by water power, the beads of the abacus in the certain forms and the like. Now, that small abacus you have a picture of right there, is no one would probably say that's artificially intelligent, or it has become AGI, artificial general intelligence. It hasn't become alive. It hasn't become sentient. It hasn't become fully conscious. It can't do intellection. Why? Because it's just wooden beads. But there's no difference between those wooden beads and the electrical voltage difference potentials that you have inside a computer, inside all those transistors. They're just voltage levels. That's all they are. Each of those voltage levels is a bead. Either it's up or it's down. That's it. And so, well, you think all I have to do then is, because computers are large, I could have lots of these voltage levels all stacked together. All I got to do is just build out this abacus, grow it and grow it and grow it. At what point does that abacus come alive? What point does it become artificially intelligent? And people would, nobody would, I think, say it would. I think somehow it's the idea that computers there's electricity in there, and that is somewhere this electricity is doing some kind of magical, mysterious thing that we don't quite understand. But voltage levels are just voltage levels. And it is we, again, coming back to that point, it is we who provide the semantics of that. It's we who interpret the output of all these things. It's we, not just the output. It's we who determine what the states even mean or say. All right. And that can only happen in a mind. It doesn't happen inside the computer. Now, Searle was one, John Searle, he died last year or the year before, I think it was. He was one of the first to make this argument, the famous Chinese room test. is one of his arguments. That's sort of well known, and that's just to give the idea of the difference between syntax, which is just a formal definition of a language. With the abacus has its formal definition of a language, what the beads mean, the position, and the computers have their on and off states inside the computer itself. Well, that's the syntax and the operation of these things. But the semantics, the meaning always comes from the outside. The meaning is always put there by us. And he has another paper, which I don't think most people are even aware of, that kind of goes into this. He asks, is the brain a digital computer? Because naturally people will tend to think, well, all right, Briggs, but the brain is obviously just a machine. And that's not true. That's absolutely not true. Because for lots of reasons. So for instance, if you say the beads on the abacus are a computer, or the states inside the computer, the voltage levels are themselves a computer, it's still we who are providing that semantic context, because a lot of people will say, well, like ants have emergent behavior. This is Searle's argument. Ants have emergent, not individual ants, but the colony has this kind of emergent behavior, being very careful not to say what emergence means. Well, and therefore it's a kind of computer. It has a mind of its own. Well, that's again our minds interpreting the behavior of this colony and assigning it value it does not have by itself. Because why stop at the ants? Why not the ants plus the tree next to it and the leaves that are moving in the wind and everything? Why isn't that a computer too? Why isn't everything a computer? Right? Everything that would be a computer like the brain is. And so well, that's what some people, they fall into the error of pantheism. They say, well, then everything is alive. Everything is a computer. But it doesn't work that way, because there still has to be something that is giving these computational states and directives some meaning. All right. And that still has to be a mind. And so Searle says they form the homunculus. There's some sort of little man that's living inside our minds that's directing the machine, a kind of a dualism. And that dualism they think is in the computer too, which I think is what the homunculus is, not a little man inside the computer, but electricity operating in some weird way. So it just isn't the case that computers are actually, that's the paper test I did. I don't know if you want me to discuss the paper test.
Sure, yeah, please.
It's very simple. A computer is just a state of ones and zeros. Everybody agrees about this with drivers and all this kind of thing, and electricity supplied, and diodes and capacitors that help direct this electricity to go where it is. But the actual brain, this is the computer language metaphor, is just a set of ones and zeros. So you could very easily, in theory, get an enormous sheet of paper and write down the state of the computer, 1 0 1 0 0 0 0 1 1, all of them, all in a row, right? And there it is. There's the mind of the computer written on this big piece of paper. Then you move the clock forward one tick. The ones and zeros will have shifted themselves in some way by the algorithm given to it by some programmer, and there'll be a new state, 0 1 1 0, and you just lay that one on top of the old piece of paper. And you do it another click at a clock and tick of the clock, and you lay that, and you do the computer again. You keep doing this, and in the end, you have a big stack of the computer states. Now, you just said the computer has reached AGI, all right. Well, the paper has too. You could flip the paper, you can look at all these ones and zeros go by. These paper must also have AGI. These also must be intelligent. And I think there's absolutely no difference between the paper and the computer, none whatsoever, except one is written by ink marks or pencil marks, and the other is done by these voltage levels, unless you think that electricity, again, has some kind of magical properties. So all of these reasons are why I don't think that we're ever going to get in a machine anything close to being, anything even close to being AGI. We can model it, but we can't reach it.
Yeah, I really like that. And then because the meaning is assigned by us, right? So, or the mind that you brought out. So it made me think about this, back to the neural net, that yes, it can look at the pattern of a shape, and it has contrast within the matrix, but we assign what that shape or means, right?
That's correct.
It doesn't know what a 3 is until we said,
And right
well,
there, what you have pictured is a nonlinear regression.
okay, yeah. And then, so this was an abstraction for us to do computation by hand instead of mind to a greater degree. But we still had to, as humans, we assign the meaning of this pattern making. So I think if I'm playing it back to you, you're right. The assignment of meaning does never show up through computation. It's there before we created the tools.
That's correct.
Right. Yeah, that's super cool. And I liked how you also brought up this one in that video, that just like a movie's a mimic of movement, there's not actual movement happening. I think that plays well with the paper stack compared to a digital version. They're the same thing, and you flip it forward and you get the horse running, but it's actually not running. It just looks like it. So that is super cool. Is there anything else that you think out there people are talking about that you think just doesn't make sense and you'd like to potentially squash it?
I've been disparaging AI, but I do want to say where I think it does a good job, because it is just modeling, and any model in which we know the causes, if we know what's causing what, and we know the conditions under which this cause can be brought about, the causal powers of some substance acting on something else. And that's we have in physics all the time. And we can get that with AI too, to a certain extent. And we do that in images. Images, everything to know about an image is in the image. It's all there. All the every pixel has a red, green, and blue, or the cyan, magenta, and so forth. We have all of that. We know where every pixel is with relation to the next pixel, and simply enough, all of the causes that produce that pixel, and then we have a label for that pixel. We have a label. Maybe it's cat, picture of a cat. So here's a label of a picture of a cat. We have all of the causes of that particular thing are there. Everything that, and the conditions, they're all there, which we don't ordinarily have. We don't have for the human body, for instance, in medicine. We don't know why someone taking a pill is going to sometimes work and sometimes not work. Often don't know, because we don't know everything there is to know what's going on chemically inside of a person. But we do know what's going on inside of a picture. So we feed this thing enough examples, the model of enough examples of cat, and then we could easily generate another picture of a cat, or a cat with a machine gun, or a cat jumping out of an airplane, and we could connect those images one after the other, and we could flip them, and then we have apparent motion, so we can have movies, and they'll get better and better. There's a lot of hard coding that goes into this too. I mean, and everybody remembers a year ago, 2 years ago, we had images with 6 fingers or 7 or missing fingers. So all of that kind of stuff can be fixed because the causes are there and they're known, all the conditions and all that kind of stuff. So AI can do a really good job in those cases, and because it does a good job, because if I ask it to generate a picture of a cat lying on a rug, it can do that. Now, what does that mean? How do I interpret the accuracy of the image in the end? There's no fixed definition of what the ideal cat lying on a mat looks like, right? So there's lots of ways for it to be right, and for us to forgive and not see the subtle imperfections in the picture and the like, that maybe a master painter or a photographer would find or something. So there's lots of ways for AI models to get it right, or for us to say that they're right or they're very good. So AI will be excellent in this. So they, AI taking over in a careful way, scenes in certain movies and the like, Hollywood is going to move to using it. That will work. That will absolutely work, and it'll do very well. Because why not? It knows exactly how to do those kinds of things. But it has to be highly controlled. Highly controlled.
Okay, great. And then I guess I've heard people confuse AI with reasoning, and I hear it all the time. Would you say then it's not possible to use AI or large language models in that context where they can reason? Is that a complete
They can't reason
false?
at all. They can only provide a simulation of reasoning. They don't reason whatsoever. You could easily give it a book of here's a book of Socratic syllogisms, whatever. This is a syllogism, of all F or G, and that kind of stuff. You could feed all that stuff in there, and then you give it instances of it, and it can perform that routine calculation for you. Right, it can spot whether, but there's still an interpretation there. So if you say if all men are mortal, this is the premise we have, and Socrates is a man, therefore Socrates is mortal. The barbarous syllogism. Okay, so we can calculate, but put all those things in there. But then we still have the act of mapping that premise. All men are mortal. All right, all F or G. We need to map whatever someone puts in their ham-handed way, for instance. And people use language, they don't use it so precise like mathematicians or logicians use it all the time. So they still have to map this to what looks like the syllogistic form. And in that, there'll be some interpretation, and error can creep in that way. So the computer is not reasoning. It's just like a calculator. You plug a calculator. I don't even have a calculator anymore. Who has
It's just mimicking
anymore?
reasoning,
You
right?
press 9 times 7 on the calculator. Boom, boom, boom. There's very little room for error there because all that stuff is hard-coded inside the calculator. But that's not hard-coded into an LLM unless they choose to. Because originally, if you remember, just a year or two ago, they didn't have simple arithmetic was not hard-coded into the LLMs, and they would get wildly wrong answers for questions like, what's 9 times 6? Or they would have, how many S's are in a word like boulevard? There are 3 S's in boulevard. So these kind of things, as long as, it's not reasoning. It's taking the input, trying to direct it to the right decision branch, and then it'll spit out the highly probable answers, and that's it.
So why is it that humans can reason, and what are we doing different than machines?
Well, nobody knows how. I think nobody knows how. That's a very good question. We gotta be careful about the. There's a fallacy that develops in that, which I have in that book. Because nobody knows how, it therefore does not mean that it can't be done, which is unfortunately what some say. I don't know how we reason. It's not something that anybody has figured out. It's called the hard problem of consciousness. Nobody knows, all right? But it doesn't prove, like some people say then, that, well, because we can't figure out how, or at least I can't figure out how, and I'm from Harvard, I have a degree, therefore it can't be done. That's like someone saying, I have no idea how a car engine works, therefore the car doesn't run. It's exactly the same error, but done, in a more highfalutin way. So it obviously works. We obviously do reason, but we don't quite know how. What reasoning is grasp. There's several elements of reasoning, right? It's first of all, it's apprehension. What is it? What is that that's being discussed? What are the terms? What do they mean, these terms themselves? And then manipulating this in a logical fashion and coming to grasp universals, coming to grasp the nature or the essence of things, right? We come to grasp, we know if someone says, picture in your mind a chair. Everybody can do this because we have come to grasp in our minds what a chair is, all right? And if you've never fed a picture of a chair into a computer and associated it with the string CHAIR, the computer will never know. It will never be able to make that intuitive leap to what a chair could or could not be. So we could do this all the time. That's what we have education for. We bring our young up to help them realize how they could make these powers of intellection by using various forms of logic and reasoning, and also various forms of induction, which we do all the time, but we don't often think about, now I'm going to use induction, or now I'm going to use this particular syllogism. We don't do that. We just think. So computers can do none of that at all. They just can't do that kind of a thing. They can mimic certain of those actions. I can associate the string CHAIR with these particular set of pixels, right? I could do that, and that's just a map, like you showed the 3 mapped to the ideal 3. I could make all those maps all day long, but it'll never then come to, I've considered this, I've considered this. You know what? I think that this thing is now generally true, like mathematicians do all the time, like scientists do all the time, back in the old days anyway. Uh, so that will never happen on a computer. It cannot.
And then, so humans can have rational thought because we reason, even though that we may not say we can explain entirely how we come to reason. This has been such a learning experience for me already. So what are you excited about now, William, that you think needs to get out into the world? I know you're doing a second edition of that book. Is there anything else you'd like to sort of like take this conversation towards that we haven't talked about that you think is worth?
I'm very concerned
Sharon?
about scientism. Scientism is more or less our reigning religion. Religion in the world has decreased in intensity and fervor, belief, that sort of thing. And we seem to have replaced it, at least in the West, and I think in much of, at least in what we used to call the Orient, with a kind of utilitarianism which sneaks in, which utilitarianism always sneaks in somebody's morals to the back door and calls it science. And materialism, in which we come to believe everything is just a machine, everything is operating as a machine, and it's the old error from Democritus from thousands of years ago. Everything is atoms in the void, just obeying rules without wondering where the rules came from. Or some scientists actually do think, oh, okay, I'm going to build a universe in my mind here, and these universes have physical laws. Where did these laws come from? They don't know. Well, they're going to be drawn from a set of other laws with other physical constants, with these particular equations driving them. All right, well, where does this drawing mechanism come from? They don't know. Nobody knows. Nobody knows these kind of things, or probably in some cases, maybe we'll never be able to know. All right. But we can't, therefore, it's the same error. Therefore, say that everything, because we can't figure it out, that it doesn't work, because obviously it does. But scientism is, which we saw in the COVID panic, particularly, where people are always saying, follow the science. Here, here's what the science says. The science can never tell you what to do, right? Science is absolutely silent on every aspect of morality and ethics. Because a thing doesn't let you move to how something ought to be without some other act of intellection going on, some sort of understanding of the nature, the essence of a thing that we're discussing. So, like I like to say, then, because of this, every time you hear somebody say "follow the science," what they're always saying is "follow me." All right. So I'm very much interested in that. I'm working
Yeah.
on a book on that. Uh, it's very difficult to think about, because so you make claims that you got to avoid fallacies both ways. I can say I don't understand how something works, and therefore it doesn't work. That's one fallacy. But we seem to have the other fallacy. Once we understand how something works, we still go on pretending that we don't. And I think education is a great illustration of this phenomenon. Uh, how many ways are there to teach a kid? You want to teach him his numbers or alphabet. Well, you can start with A, and then you can move to B and C. Okay, maybe I could write a paper saying, well, it'd be better, we have better results if we start with B, rather than A, and then we'll go B, C. There's 26 different ways, or 26 factorial ways if you want to order them in a different way, But there's limitations that we run up against that we could know about how to best educate children, and we probably hit most of them. Yet the field continues on, piling on, because of scientism, piling on morality and ethics of the paper writers, thinking they've come up with new ways to learn how to teach somebody. And I don't think it's true. I don't think that there are infinite numbers of ways that you could teach anybody. So these kind of scientific fields, or they purport to be science, well, they are science. They're just bad science. They're bad science, and they're conflating again. It's always a way to sneak in the back door somebody's morals, to impose their beliefs, as opposed to your beliefs. That's the imposing your beliefs fallacy. So, and it's very difficult to make this stuff clear. I'm not even sure I've made it clear to myself, let alone to your listeners out there. It's very uh, it's a hard task to keep all of these things in mind at once. And that's what I'm asking people to do. It's to break away from our traditional modes of thinking. And that is always tough to do. Very tough to do.
Yeah, I agree 100%. And why do you think that is maybe about human nature where like not everybody is willing to flip mental models or to even uh, agree that they were wrong? There's something we hold on to. I don't know if that's a conditional thing through environment where people become sort of calcified and stuck into their ways that they're not willing to switch.
I think it's just human nature.
Yeah.
Most of the time, we don't need to. For most people, in most instances of most of life, we don't have to.
Yeah.
With my belief, it could be wrong. As we talked about at the beginning, it could be wrong, but it's useful. It's useful to me. I'm getting along with it. Why should I change? Why should I change? Because it's useful to me in some ways. So that's why you could demonstrate. We could demonstrate to people all day long, like these forecasts, these environmentalist forecasts are absolutely wrong. They have no bearing on reality. It doesn't phase them because that's not how they're judging these models. That's not how they're judging the model's worth. That's not their belief is stronger
Yeah.
because that belief brings them other rewards. Matching reality is one reward, you want to call it that, but these beliefs then give them something else. They match other bits for them, and that's why they tenaciously hold on to these beliefs.
Yeah. Yeah.
And that's most people in most things.
Yeah.
It's not, you could look at mathematics and you could say here you can. Everybody agrees this is our most rigorous form of reasoning that we have. Mathematics. Let's say that's true for the sake of argument. If you don't believe it, you could. There's acres of publications that come out every year with all these things, and nobody can master it all. Not everybody can even master some of the more than the basics. All right. There's limitations that all of us have. And it's rare for people to have and the sorts of abilities to intelligence, aspects of intelligence that are able to think in new ways. All right, it's a very extraordinarily difficult thing to do, even for people who are ordinarily intelligent. Again, because what they have for them is working, and it's meeting their needs. All right, it's meeting their needs. So I think it's just a limitation. People are unequal, and equality, which is one of our reigning myths, in the sense of, I hate to use the word myths. It's a falsity. It's not true. It's an error. It is a mistake. People are not equal in their intellective abilities, and that's just tough. We'd want it to be otherwise, but it's not so. Just like not everybody is equally tall or short or fat or whatever. And we'd like all that not to be so, but it isn't. Inequality is the state of the world, but we would rather believe otherwise, and that's a shame. Every age has its own errors, and this is
Yeah.
ours.
Yeah.
So
And
we'll move to new errors once we fix these. It's not going to be that we move to some utopia after we fix all these things that Briggs is telling us, then we really have it good. No, I don't know what the next errors will be, but they'll be there.
yeah. And it feels like, and I think in your other video I watched, when you bring up follow the science, it's even you saying that putting the word the in front of it changes the meaning of what science is. And I found that I've seen this with my kids in high school too, where they started to frame science differently. I'm like, what's the process of trying to figure out if a hypothesis is true or not? And at least that was my perspective of it. And the school was starting to reframe it. And maybe what is it that changes when you put the in front of the word science?
The
How does that
science makes
change
it
the
turn
meaning?
into a adamantine set of beliefs that no one can question. Here is what the science says. No one can dispute this. No one can look at it and say anything different. If you do, you're a denier. You're a denier. You deny this. Most people who tell you to do this, and they say the science. Even the scientists themselves don't even understand everything that's going on in a particular phenomenon they're trying to explain. They're mystified about all the causes involved and everything. But here is the science we must all agree upon. It's a political tool, nothing more than that. It's propaganda. There's never the science. All right. It's not that it's wrong to search for absolute or necessary or universal truth. This is the goal of science. The goal of science is to find these absolute necessary truths, dogma, and to define this dogma and to work from that and build on it. That's not wrong. And that's what we should be doing in all matters of intellectual endeavor. But
Hmm.
in science, a lot of the times, most of the time, we don't have any idea what's going on. For instance, quantum mechanics is
Yes.
the reigning paradigm in physics. No one understands quantum mechanics. There's lots of ideas. Maybe someone's got it right, but it doesn't seem that anybody has the full picture on this kind of. So there is no the science to believe there. There's room for dispute, and especially in complex, highly complex system, hideously complex things like our bodies, and people and interactions between people. So when anybody is saying the science and those kind of things, you're almost always being hoodwinked.
Yeah, it feels like they're weaponizing the field or the process or the ability to question and saying, well, no, we already did that for you. Just do this and believe us because we did the science. So follow the science, instead of having your own perspective of challenging ideas. So this was a very insightful conversation, William. I was really looking forward to having a conversation with you, learning a ton already, shifting mental models just by having a dialogue with you. So where can people find you as we just sort of like wean off here close to the hour? I know you're working on that second book or a revision of the second book. Where would you like people to find you? I could put in the show notes after. Or would you like to leave anybody with anything else while we
Sure,
close out?
I'm at WM Briggs Substack, and I have a YouTube channel if you prefer videos at WMB. Easy. And I'm at Twitter. This is not so easy. I'm a famed celebrity. I have my name originally a long time ago, but I was booted off Twitter several times during the COVID panic uh, for giving what were then unpopular views about how to react to what was going on outside our windows. So I thought everybody listens to celebrities, right? And because they're our highest authority, I mean, we have to admit. So I will be a celebrity, and everybody will have to listen to me.
Awesome. Okay, well, I'll leave that in the show notes. Thank you so much, William. I appreciate your time and had a great conversation with you today. So looking forward to following more of your work, and I'll share everything in the show notes for others to follow you. Thank you so
Thanks
much.
very much for having me. Appreciate it.
All right, William. Cheers. Have a great week.